Okay, so hi everyone, welcome to this event on cloud computing. Just a heads up that this evening we will be recording the event, just so that people who weren't able to make it are able to watch it back again. All right, so yeah, we'll more or less jump straight into it. So it'll be myself and Kyle Davis. So Kyle, something has come up for him. He may be joining us a little bit later. His section was on DevOps. So there'll be a little bit of a section on DevOps if he is able to join later on, but we'll proceed on anyway. So the plan for this evening, we'll just quickly explain, what cloud computing is in the general sense, why it is, useful, and some general examples of where it's being used in the industry. We'll look at a quick, we'll try and keep it as short and sweet as we can, main example-driven introduction into AWS. So we'll look at a couple of client-server architectures and a serverless architecture for a web application. So think, a shop or a blog, that style of thing. And we'll see how it's actually deployed in the cloud and how the cloud is used for that. And then if Kyle is able to join us, he'll do a little section on DevOps. But the main part of this will be your breakout exercises. So we've got some hands-on activities to go through at the end, and this will get you sort of rolling up your sleeves and having a go with AWS to deploy a couple of simple architectures so that you can get that experience. Okay, so the lab exercises should take around 30 minutes. But they may take you a little less time or more time. It depends on your experience with AWS so far or cloud in general. There's no set time really. That's just sort of a guide. So in terms of this section, we'll look at what the cloud is. Where is it? Because it's not in the sky. We'll look at the demand of cloud computing within the industry. So in terms of where does it stack up against other hard skills? Why is it so valuable to industry? We'll look at the careers and some general, as I say, companies that are using the cloud. So just move this out of the way. Okay. So yeah, in general then, the cloud is essentially just a service-rich set of data centers. So at its core, it's a load of data centers scattered all around the globe. Across all North America, South America, Africa, Europe, Asia, it's everywhere. The main point of value with the cloud is that it's on demand. In the traditional sense, before the cloud was a thing, if you wanted compute capacity, and processing capacity, you had to stump up the cash to buy your own sort of data center and your own equipment. And if you're a company, especially a small company starting up, that is quite difficult to do. Especially if you're doing something which requires a fair amount of compute power, you'll be spending a large amount up front to be able to do that. So the idea is that it's pay as you go and it's a pay for what you use sort of model. So this drops the barrier to entry, I suppose, into the digital world to now make it accessible for everybody. So there's no need to manage your own hardware. There's no need to actually repair it if it goes wrong. And by service rich, what do I mean by that? Well, essentially, it's more than just a load of data centers. It's more than just a load of servers that sort of stacked up together. The real value of it is the services that are actually involved, and the services that are running on those servers. So you've got a massive range of compute, so VMs and things, and storage solutions. A huge part of this as well is things like robotics and machine learning and media services and IoT. So it's essentially a massive toolbox of useful things that allow you to take ideas from concept to delivery much more quickly than what would be the case if you were to do things manually. So where is the cloud? As I say, it is everywhere. So this is just a map of the AWS regions. So a region is essentially a particular part of the world which has one or more availability zones. So an availability zone is essentially think of it as a data center, an individual data center. And regions are made up of several of these data centers. So that is what forms that. And we'll look at the value of having multiple data centers in a region in a little while. An edge location. these are popping up all over the place at the moment. So essentially what this is, it's see it as a kind of a more stripped down version of a region or an availability zone, in the sense that the main focus of it is to cache your content. So if, for instance, you've got a website which is running, if it's just a website for, if it's a blog or something of that nature, then the blog content will be cached in a very localized location to you. So the blog might be hosted in, for example, the East Coast of the United States. However, you might be accessing it from China. And from there, the Chinese edge location, or the one that's close to you, would actually cache the whole blog, which means that when you request to access that blog, it comes from a very close edge location rather than all the way from America. So this is particularly useful for larger files, videos and streaming and things like this. So in terms of the demand of the cloud computing skills within the industry in general, so you've got your soft skills, things like creativity and collaboration and things. But cloud computing has persistently over the last few years been ranking very highly in all sorts of areas. Blockchain is staying as number one. So that's that distributed kind of storage of data. You may have heard of Bitcoin and Ethereum and things. Those are based on blockchain, but it's much more than cryptocurrencies that you can do with a blockchain. And AWS is one of those services which is now possible to sort of manage and run your own blockchain in the cloud. So yeah, the cloud is pretty much covering everything in terms of AI as well. And business analysis, all of these things can be done within the cloud. So this is why it's so valuable. And as you see here with some of the certifications, I've just pulled a list of the top paying certifications in the industry. This is the average salary of somebody who answered a survey and holds this particular certification. You'll see there you've got it's a mixture of cloud security and project management style of thing. So yeah, you see there that those are the main sort of areas that are really well, they're really quite lucrative as well as being in heavy demand in the industry there. So from the business perspective, why is it valuable? Well, as we said, it's all about lower costs, and it's all about less responsibility in the fact that you don't have to manage the infrastructure yourself, and it's Amazon or Google's or Microsoft's problem. If something goes wrong in the data center, from a security or an availability perspective, it's their responsibility to actually fix it. And all you have to care about really is the things that are running on the servers, your software and your applications. It's a much lower carbon footprint as well. The cloud data centers are making it a priority to use green energy to power them. And as I say, it's easier to do complex things. So things like machine learning, which we'll look at literally on the next couple of slides. So things that would be very difficult to do yourself, you're able to leverage cloud services to do all of the work, and then you literally just use an API to feed it data, and then it will give you a response in that way. And you're able to scale to meet any demand as well, which is one of the huge things. So as I say, traditionally you'd have to provision your own data center with, say, 50 servers because you're expecting 10,000 users or something like this. Whereas now you can provision, just a baseline of 2 servers and only pay for those 2 servers until the demand increases, and you can automatically increase the number of servers you've got running because it's all virtualized. So you can see some stats from Salesforce along the top there. Ultimately, it's something which grows revenue and it's something which lowers cost. So it's from that alone, amongst the other things, it's very useful. So careers related to the cloud. I just pulled a quick list. It's not, if people sometimes wonder, okay, when can I use the cloud? Well, you've got these sorts of roles here then. So things like solutions architects and web developers and data scientists and app developers, cyber specialists. So really the cloud is able to touch more or less every digital or tech occupation in some way, because of it's so multifaceted, and you can do so much with it, especially around big data and AI as well. Those are huge. They can really speed up your job, as it were. And these are all pretty interesting jobs as well, so definitely have a look at them. So in terms of real companies that are actually operating in the cloud at the moment, you may be surprised to know that Netflix is actually running in AWS. So of course, there's Amazon Prime Video, which is run by the same company that runs AWS, but Netflix is still actually running all of their infrastructure within the cloud. And this is a $227 billion company that is doing that. You may have heard of Coinbase, which is a cryptocurrency trading app. They were valued at 8 billion a few years ago. They as a startup put everything in AWS, and it's just now scaled to the point where they're an $8 billion company. So it just shows that it's able to scale quite significantly. The US government also uses it quite heavily. PayPal runs a fair amount of stuff in Google Cloud. They're a very valuable company. You've got ASOS, which you've probably heard of, which is that online fashion retailer. They've got what's called a hybrid cloud architecture, which is they've got some things running in their own data centers, and then they've got like the website and things running in AWS, and they're able to connect those together, and communicate data between the two of them. PlayStation Now, so Sony is a $112 billion company. So Sony is running their PlayStation Now, the game streaming service in Microsoft Azure. So all of these big companies that could probably afford to start their own data centers, they're all choosing to run things in the public cloud because of the fact that it's so much cheaper and it's so much more agile to be able to do that. Okay, so that covers a quick primer, and hopefully that will help you to understand what the cloud is and in terms of what it's all about. So let's just have a look. So in terms of this section, we will just quickly cover then, some machine learning services, and we'll look at the solutions architecture for a client-server web app and a serverless web app. So serverless is one of these big phrases that's been coined, but we'll see what that's all about in a little while. And we'll do a quick comparison of Google Cloud and Azure at the end there. Okay, so the first machine learning service I want to look at is AWS Recognition. So this one is probably one of the coolest AWS services, and it'll enable you to actually do through computer vision, object detection. It can detect faces and tell you if two faces are the same. It can spot. If you were to set up a camera, it's able to spot, has this person been here? But the best way that I can explain this is through showing you a demo. So I'll just pull up the browser. So this is the demo for recognition. You'll have a go of this a little bit in the labs as well. But it just shows that it's able to detect objects, and particularly this is quite topical at the moment, where it's able to detect if somebody's wearing gloves and if somebody is wearing a mask. Okay, so this particular demo shows quite well in terms of what it can do. It'll tell you if there's a face cover on the nose. It'll say, are the hands covered? And it'll tell you who or how many people are not wearing a mask and all of this sort of thing. Something else, for instance, you're able to have celebrity recognition. Obviously, Jeff Bezos has called himself a celebrity. But it's able to tell you, who is in the image, kind of thing. And you could load your own database of faces, and it could do the same thing. So there's also, it is a little bit draconian, maybe to some people, but I mean, this stuff is very, very powerful. So, it's able to tell you, from a face, it looks like a face. They're able to tell you how old this person is. Are they smiling? Do they appear to be happy? In terms of objects, it's able to tell you that there's a car, that there's a skateboard, that there's a person. The stuff that you can do with this is ridiculous, and it gives you all of the data as like a JSON object in return. So you're able to just give this thing an image, and it will spit out and tell you what's in the image. So the stuff that you could do with this is crazy. Amazon Comprehend is another one. This is all about natural language processing. So named entity recognition is one of the things that this is normally called as well. So if you go to Comprehend, so let's just have a look. So I've got a lump of text here that's just got, you know, someone's name, a few bits and pieces of data in there. But what it's able to do is named entity recognition. So it's able to tell you, you know, what is in the document. You know, it's able to detect that Zhang Wei is a person. It's able to detect that it's that this thing is an organization, that is, for example, that's an address, and that's a quantity. You've got PII, which is personally identifiable information. So it's able to detect if a document has got bank account numbers in, if it's got a credit card number, a phone or an email address, or a name. So, you know, if you were, for both good and bad, this is, obviously I'm not condoning, don't do anything illegal with it. But, you know, if, for instance, if you were a forensic investigator, this sort of thing could be quite useful as well. You could just ram a load of text through it and it will tell you, is there personal information in there? And it's also able to say, you know, through sentiment analysis, is it a positive piece of text? So imagine if you've got a reviewing system, and you just launched a new app or a new product, you could run all of your reviews through this, and you could gauge how many of them are positive, how many of them are negative, how many are mixed, how many of them are neutral. You know, so it's able to be done all completely automatically. And again, it will give you the output of this as literally just a JSON object, and it will tell you, you know, all of the different things about it. You know, what the key phrases are, and what the names are, and what the credit card numbers are and things. So it's you can incorporate this into your own applications quite fluently. A couple left. So you've got Amazon Transcribe. This one is all about speech to text. So for instance, with Amazon Transcribe, one of the things it's able to do is essentially read from an audio stream. So imagine your microphone. So, or this could be, so it could be your microphone on your computer. It could be a microphone attached to a robot, or set up somewhere else. It's able to actually differentiate between speakers as well. So for instance, if there were multiple presenters in this presentation, we'd be able to record the audio stream of it, and it would automatically build a transcription of the presentation, and it would be able to tell who is saying what. So it's not just about speech to text, it's also able to differentiate between who's just said it. And you know, the things you can do with that are enormous as well. It's also able to, you know, automatically filter out vocabulary. So if you wanted to censor swear words or particular other phrases, then that is able to do that automatically as well. And again, it's all, you talk to this service through an API, so you pull the output into your application and deal with it there. And again, all of this stuff, you see a common theme with this. It's very difficult to do this yourself and code this functionality yourself. So the cloud is not about the servers, it's about the stuff that's running on the servers, and how agile the servers are. That is the value. At its core, obviously, it's just a load of computing equipment sat in a warehouse type building. But it is in reality a lot more than that. So the last one, just to show you, is Amazon Lex. So you may have heard of this. This is a chatbot type system. So this will actually enable you to have like quite lifelike conversations with a chatbot, and you're able to do, you know, interactions such as placing an order or tracking an order or booking a hotel or booking an appointment, this kind of thing. And we're seeing more and more of this actually, both in like customer service and sales contexts as well. But you can basically create your own chatbot fairly easily through this. So I'll just pull that up. So I've spun up a demo chatbot. So this one is all about running booking a hotel. So for instance, if I wanted to say to the chatbot there, I'll just try and zoom in. Okay, so let's say I want to book a hotel, and then it will ask, what city will you be staying in? We can say London, and then it'll ask me, when do I want to check in? So let's say that we want to check in on Friday, and we can say that we want to stay for 4 nights. It'll ask us what type of room do we want. We can say king, for example, and then it will confirm with you the details, and you can just say yes. And then what would happen at that stage is you've literally given it everything it needs to book a hotel room. So you'd hand off that response to your own system, and then the booking system would just make sure that that room is booked for this person. So you can see how useful this would be on a, if you had a hotel website or a parking website, something of that sort, that would be very useful. So that you can do many things with this. This is just a demo. So, you could build up your own conversation structures with it as well. But that's just to give you an idea that it's quite intelligent as well in terms of the chatbot, in terms of how it engages with you. So you can only give it a few sample utterances and it will be able to work out what's being said most of the time. Right. Okay, so that covers our sort of look at the machine learning services. So just pull this back up. Okay, so we'll just look at a client server web app then. So we've looked at like the machine learning side of things, but I also want to look at the infrastructure side. So this will essentially be us deploying a highly available and scalable web app into the cloud. And we'll look at what each of these components, so these are the main components that you would want to actually implement an architecture. So we'll go through each of these in turn. I'll try and explain them fairly quickly, just so that we can get to the point where we pull them all together and you see how they work. But again, with all of these, they have no upfront fees. So, as before, if you had your own data center, you would be paying up a large amount for these VMs and for the storage and things. Right, so the first bit is Elastic Cloud Compute. So this is just look at it as servers or virtual machines. Okay, so at the core, all these are computers that are running whatever you want them to run. So it's compute capacity. They have RAM, they have networking, they have an ability to communicate with each other and things. So they run just Windows or Linux, any operating system that you can really give it. They're vertically scalable in the sense that if you were to start it off on 4 gigs of RAM, for example, or a certain amount of CPU capacity, you'll be able to scale that up at the click of a button. Whereas again, in person, all that you would need to unplug the server, you would need to physically add more RAM, physically add a different CPU, but that is not necessary with this. So these are servers. EC2 is servers. Elastic block storage. So what is this? This is, look at this as a hard drive or solid state drive essentially, and this will plug straight into the EC2 instances. So with your VMs, the VMs on their own, of course, they need storage. So this is just a virtual hard drive that will plug into that. You can get magnetic storage, so that tends to be cheaper, but the things that people go for these days a lot of the time is just the general purpose solid state storage within servers. And again, these are still extremely cheap at like 10 cents per gigabyte per month. So again, businesses see this and they know that on balance, it makes sense financially. So a relational database, so RDS. So in terms of what RDS is, it's a highly available, we'll cover what that means. It's SQL database solution. So you've probably heard of MySQL or Oracle or Postgres or Microsoft SQL Server. Well, RDS will run one of these database management systems. And again, in the context of an online shop, the database would be holding customer details or stock details, reviews, things like this. Well, in this case, in terms of why it's highly available, is that you will have sort of one instance of your database that might be like a 16 gig, quad core, whatever instance that would be running, for example, Oracle for your database system. However, the thing is with this, if that database system was to sort of fall over or become unavailable or crash, or the whole data center that it's in sort of like gets struck by lightning or something like this, some reason that causes the database to stop working, well, it'll have an automated standby replica. So you can actually deploy this over 2 availability zones, so 2 separate data centers. And if your primary instance of the database fails, then automatically all of the traffic will be rerouted to the standby replica. So your application, despite the fact that potentially an entire data center has been destroyed, your application will carry on running. So this is about high availability again. It's able to sustain faults where normally under normal circumstances, the whole thing would come falling over. Virtual private cloud, just put simply in terms of what this is just a virtual network of sorts. So you think of your routers, your switches, and your subnets. This is all of that, but virtualized. So you have your network in your house, for instance, you've got your router, you might have a few Ethernet cables coming out the back of it into a Skybox or into a computer or PS4 or things like this. But this is just all that virtualized. So this is what enables the EC2 instances and the RDS, so the databases, to actually talk to each other, because everything is its own unit. So of course the networking is necessary for that to happen. So it just enables the data to travel to other parts of your infrastructure. So it's a fundamental component of the cloud. So security groups and NACLs. So a NACL is a network access control list. So just think of it as a security group. It is just something which will protect individual virtual machines, so EC2 instances, and it will basically govern, okay, what ports are open for inbound and outbound traffic, and where can the traffic come from, or where can it be going to. NACLs will do the same, but they'll do that at the subnet or the whole VPC network level. So security groups govern individual subnets, individual instances, and NACLs will govern whole networks and whole subnets, and essentially be that line of defense for what can come into this network and what is allowed to go out of the network. So that's what those two components are. Again, it's only important to sort of roughly know what they do at this stage. So in terms of auto-scaling groups, so these are actually brilliant and one of the most valuable things in the cloud. So as I was saying before there, so you're able to set an auto-scaling group with an initial capacity of just 2 servers. So say you've got your online shop or your blog, and you're just expecting, like, I don't know, 1,000 users to be watching or to be on the shop at any given time. Well, say for instance, if you were to launch a sale or you were to receive, a load of good press coverage, your users might jump from 1,000 to 10,000 or 50,000 users, potentially in a case of minutes or hours. And for you to be able to respond to that, if you've only physically got 2 servers, obviously your application is not going to be able to sustain that increase in load, and you're going to lose sales and the users are not going to be able to get through. So with this, it will automatically detect when a certain metric has exceeded a threshold. So for instance, say you set that threshold at 70% CPU utilization, or a certain number of megabits per second leaving the instance, you can measure how much load the instance is under and then essentially scale out on that basis. So you'll go from 2 servers, it might add a couple, and then a couple more, and a couple more, and a couple more. It'll keep sort of adding these other servers until it's able to cope with the demand that's being placed on it. So, until you're staying consistently on average below 70% CPU usage. And again, this is all completely automated. So, there's no massive panic when, in the data center, when, when the infrastructure is struggling to meet demand. And of course, when things quieten down, the instances will automatically shut down in turn, and then you'll come back down to 2 instances or 4 instances again. So they shut down to save you money. So this is the elasticity part of it. It can scale both up and it can scale down automatically and very quickly. So application load balancer, just see this as essentially the dealer of the instances. So say you've got 5 instances running, the application load balancer will take the requests that are coming from the users. So you've got your shop, you've got customers that are coming onto the shop, their requests will come through into the elastic load balancer, and the load balancer will decide, okay, instance 1 is struggling a little bit, instance 2 looks fine, send the traffic there. So it will keep things fair across your instances that are running, so that no one instance is receiving more traffic than the other. That's essentially how that works. You can run health checks as well, so it's able to automatically respond and detect when a particular instance becomes unhealthy. So if a server becomes unresponsive, you obviously don't want to be sending users to that server. So it will automatically stop sending traffic there if it detects that it's not responding. And then eventually that will just get closed down and replaced. So yeah, the last one to cover then is Route 53. This is DNS. So for instance, say you've got a website that sells footballs. So you have footballs.com, that's your shop. So in order for your web browser to be able to visit that shop, you have to firstly convert footballs.com into an IP address, because that's how the network will actually transit your request. Because within TCP/IP, you need that IP address to be on the packet so that the routers know where to send it, and indeed for you to get the page back from the server afterwards. And so at its core, this just turns a web domain name into an IP. You've probably seen this before. There's DNS. There's all sorts of different DNS services. So domain name service. Again, there's no need to understand this in too much detail for the sake of this. Just know that that's roughly what it does. So we'll just look at quickly then a solutions architecture for a client-server web app. I will say we've only got a few more slides to go, and then you'll be straight on to the lab. So there won't be too much longer of me talking. So just look at it in 3 different layers. So you've got your presentation layer, your application layer, and your data layer. So the first one, just look at this. Think of it like a restaurant. So the first layer is like your cashier or your waiter. So they are the ones that take the order or take the request from the user, and then that will actually be passed on to the chef or the fry cook, so somebody in the kitchen. Look at it that way. And then, when in the kitchen, the chefs may well go to the fridge or go to the the cupboards and things to get pots and pans or ingredients out. So just look at it in these 3 layers. It works very similar to that. So your user's request will come in. And it will hit, your Apache or Nginx server. So they'll just take your request, and then they'll be passed on to your actual web application that's running, Python or ASP.NET or Java, and that is where the work will actually sort of be done. And that application layer may well talk to the data layer. So, for instance, with the shop, your application code would need to pull product information. It may need to pull reviews or images, things like this. So it may well pull these from the database, and then the page will get generated and literally just returned back to the presentation layer. So Apache and Nginx will then push that back through to you, and you'll see the page. So underneath the bonnet, this sort of structure is how a basic, well, certainly not basic, but sort of a typical web application stack would look in the cloud. And again, this is across 2 availability zones. So if one whole data center was to fail, then your application is not going to go down. And again, with the databases, if your main database fails, there's a replica standing by ready to go immediately if it fails. And all of this stuff takes place on its own. So you see the value of this more or less straight away there. I'm conscious of the time, but we'll just look at this very, very briefly. So serverless at its core, again, there's only just one more slide after this. So at its core, then, this is just about running code and doing or trying to mimic the behavior of a more complicated infrastructure like this, but without actually setting up any servers at all. So with Lambda, for instance, you're able to just run code in the within the clouds without having to set up your servers or install Python or install Java or any of this. So all you're doing is actually running code straight away without having to worry about all of the technicalities that are taking place to run it. You just care about giving Lambda your code, and it will just take input, run it, and give you an output. It's as simple as that there. So we'll just look at a basic infrastructure here. So what's happening here is we've got a voting web app. So a user will basically come on and cast a vote for something. So, it could be, what's your favorite food or what's your favorite color? Let's just think of something simple. So the user will actually log in. So they'll log in there and with a username and password. So they'll get a cookie that'll get stored in their browser. That's then their ID badge to actually continue with the transaction of voting. So what will take place there is the user is able to cast their vote. So let's say that they vote for red as their favorite color. They'll cast their vote through the web app. This will make its way into API gateway. So just look at this as the front door to the Lambda function. Okay, so your Lambda function is running a piece of Python code or a piece of Java code, and the API gateway is just sort of like a HTTP endpoint. So it's like HTTPS:// something or other. So it's where you send the vote. Okay, so then it'll hit that gateway, and then the data will get passed from the gateway into the Lambda function. And once the Lambda function or your Python code has got that vote, it's able to actually, take your name, take the vote, and just store it in a database into DynamoDB. So DynamoDB is just a serverless database essentially. So again, it's almost infinitely scalable, and it's a NoSQL database. So you may have heard of MongoDB and things like this. It's essentially the same as MySQL and Oracle, but with a more relaxed structure and a more relaxed schema. So there's no need to stick to any particular structure there. But again, the main thing with this is traditionally relational databases are quite difficult to scale. So for example, with MySQL and things, it is very difficult to scale that out. Whereas with DynamoDB and other serverless opportunities, it is much more easier to do that. So again, with serverless, the real power is in the scalability and the availability of things. So essentially, DynamoDB is able to say or detect that the vote has changed, or that the total has changed for the color red because the user voted that red was their favorite color. And then another Lambda function there, another piece of Python code is able to get the new total and just regenerate the results page for this voting. And then it will store it in an Amazon S3 bucket. And S3 will be explained more in the labs that are coming right after this. But look at S3 as just cloud storage. So it's basically just like your Google Drive or your OneDrive. It's very similar to that, but it's designed to be more cloud sort of friendly, and you can use it to actually host a website without setting up any servers, which is one of the tasks that you'll do in the labs just after this. So again, this will just get stored. So a HTML file with the voting results will get stored on in an S3 bucket that's actually viewable to the world. So anybody can actually view that voting result in that way. So the very final step of this then is that the user will, they'll go to like votingresults.com, for example, and then they'll request that, they get the IP address for it, and then they hit a CloudFront distribution. So very, very briefly, CloudFront, all that is a content delivery network. So you may have heard of CDNs or content delivery networks before, but essentially what this will do is it will cache the voting results page, because it's just a static piece of HTML. For example, this S3 bucket, so this cloud storage, may actually be in America, but again, you may be in Africa somewhere or Asia. So that voting results page will get cached all over the world, so that whenever say you're sat in, again, Japan or South Korea somewhere, then you will be getting the results page from a very local edge location. So for example, it may be 10 miles away or 50 miles away rather than thousands of miles. So yeah, that is essentially what is happening there. We try to keep a fairly simple architecture, but that will be looked at a little bit more in the labs. All right, so this is all of the explaining and things done. Within about 2 minutes, you will be in the labs. So yeah, right, very last section. You may have heard of Azure and Google Cloud as well. This is just to stress that, there are other cloud providers out there. It isn't just AWS. There's also Google Cloud and Azure and IBM and Oracle. They've all got their own cloud services. And a lot of them do fairly similar things. It's just that, certain providers are better, well, arguably better at other things. So for instance, one of the big strengths of Google Cloud is its containers. So it's like, it's got Kubernetes and Google Cloud Run as well. But this table here just shows you, if you're given some, a problem to solve, it isn't necessarily a total deal breaker in terms of going with one provider or the other. So whilst this, this lab and this session is mainly about AWS, it's not to say that that's the only option. For instance, with your where we've got EC2 in AWS, you've got Compute Engine and virtual machines in Azure. So, and all of these, by the way, have got, free trials and free tiers or student credits and things like this. So if you want to have a go at them, and use what you've learned today or from elsewhere across those other providers, then it's also possible to do that as well. And I would actually encourage that. So you'll actually find if you learn one cloud provider well, you'll have a massive amount of transferable knowledge across the others, because the concepts are all the same. Once you've got that foundational knowledge of cloud, you are very versatile across the others as well. So that's the main sort of information giving part of the presentation. So I appreciate your attention for that. So with the labs, what we'll do is there's a PDF. John, have you got do you want to send the PDF to the chat? Have you got the link?
Yeah, I'll just send them now.
If not, I'll send it. It's fine. Right. Okay, yeah. Okay, so John has just put a link in the chat. That will give you a PDF, which, of course, we'll go into the breakout rooms in just a second, but just to show you, we've put together a series of exercises, and the idea with this is mainly because the machine learning services are very interesting. We want to sort of get you, into AWS and playing around with those, particularly, recognition and comprehend, and transcribe and the chatbot Lex as well. So these are the very sort of low barrier, very visible, quite fun to use and play around with sort of services. But within there, we've also got, implementing your own static website. It'll guide you through it step by step. And in addition to that, at the end, there's just like a basic API. So we talked about Lambda and how Lambda literally just takes code and runs it. Well, one of the exercises there in the labs will just be, and again, if it didn't quite make sense the first time, I'll try to explain it again in the labs. But just look at it as something that runs code without any servers. And that's all that it is. So you'll be able to go through, have a look at, follow the instructions essentially. And the idea is it'll just give you that experience to, to take away and potentially use in group projects, or if you think of any extracurricular projects, because it's all about starting fairly small and building your way up, and you'll progress quite quickly. It's quite surprising. So what we'll do at this stage is we'll put you into breakout rooms. Just to mention that we are, there's this thing going on at the minute called AWS Educate Challenge, and we are actually number 3 in the UK. We've managed to keep hold of this. So at the end of the labs in task 8, the AWS Educate Challenge will be explained as well. But there's essentially a load of prizes that you can get at both the individual levels. So the top 30 students in the UK essentially get to meet, sit down and meet with a load of Amazon employees, and they win vouchers and Alexa devices and things. And also at the university level, the top 10 universities in the UK will receive a trophy as well. So we're just trying to stay high on the leaderboard at the moment. So you can get involved in the AWS Educate Challenge at the end of the labs. So just jump to that. So at the end of this, at the end of the labs, there will be a feedback form. We would appreciate it if you could fill that out as well, just to let us know how the event has gone. All right, so we'll just pop you into breakout rooms now, and as I say, so you can get that hands-on activity and really try and build your skills and incorporate the knowledge you just got from this presentation. All right, so we'll just pop you in there now.